With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states a hemispherical bowl of radius r carries uniform surface charge density. So this simply means that the charge is simply present on the surface charge density sigma. Find the potential at the topmost point A. So you can see that this is the topmost point on the surface of this hemispherical bowl, taking the potential at the infinity to be 0. Now we have to take the potential at the infinity to be 0 and we have to find the absolute potential at point A. Now let us try to find out, let us try to see what is the main concept that we will be using here. For that, let us draw a diagram. Now let us assume that we have, this is a hemispherical bowl, right? So let us complete this sphere. Let us add the other half hemisphere. So then this will become simply a sphere. Now let us first try to find out the potential at the center, right? Let us take that as VO. Let us try to find out potential at the center due to the sphere. So we can find out the potential at the center is simply equals to the potential due to this hemisphere that is here and the hemisphere that we have added, right? So let us take this first hemisphere and let us take this as the second hemisphere. So the total potential at the center will be simply due to both these hemisphere. So this is due to simply the hemisphere first, let us say VH1, and the second hemisphere. Now, since both the hemispheres are identical, then we can see that the potential at the center is simply equals to 2 times the potential due to hemisphere, right? So what is the potential due to sphere, right? What is the potential due to sphere at the center? So at the center, if the surface charge density is simply sigma, then the total potential at the center is simply sigma divided by epsilon naught into r, where r we are taking as the radius of this sphere, right? So r will be simply the radius of this sphere. This is the value of potential at the center. This is simply equals to 2 times potential at the center due to the hemisphere. Now this is due to this hemisphere or this hemisphere. Now from here we can find out the potential at the center due to a hemisphere is simply equals to sigma divided by epsilon naught into r by 2. Now we are going to apply the main concept. You know that the potential due to a sphere or a hemisphere is same everywhere. So you can see, let us say if this is a sphere, so if we take potential at any point inside or on the surface of this sphere, so the potential is simply same at the center or at any point in between or at the surface. Same is the concept here. We have found out the potential at this point. So we have found out this is the potential VH at this point. This is VH here. So VH is simply equals to VA because the potential due to a sphere or a hemisphere is same as that at the center and at the surface. So this is the main concept. V at H due to this hemisphere is simply equals to V at O, V at A, right? So this point is simply A. Now from here we can find out the potential at A simply equals to sigma divided by epsilon naught into r by 2, where r will be the radius of this hemisphere. Now we have to find the potential with respect to the infinity, right? Taking potential at the infinity to be 0. So this will be the absolute potential. So this will be the absolute potential because we are taking the potential difference. So this is VA minus V infinity is simply sigma divided by epsilon naught into r by 2. So we have found out this assuming V infinity to be simply 0, then the potential, absolute potential at A is simply sigma divided by epsilon naught r by 2. This is the final answer. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.